Okay, this is sections 1.3 and 1.4. We are solving systems with Gauss-Jordan, Jordan, reduction. Okay, so the reason I'm putting this together is, oops, I spelled Gauss wrong. G-A-U. I don't know why I did it the other way, but anyway. I'm putting these together because I don't see any reason to really separate them. They're all this one idea. Now, I will say well, I guess I'll use the same notation the textbook does. Now, we're going to see that we can do this with with Sage, with technology, but we should also know how to do simple cases for ourselves. Big cases, we'll just use technology. Simple cases, I'd like to see that we can do the work ourselves. And so suppose, now I'm kind of taking an example from 1.3 where they do the step-by-step stuff, and so it's going to be sort of a silly example in some ways for a system of equations, but nonetheless, let's say I have a system of equations that is 4x3 equals 0. See, that's sort of silly because right away I know that x3 has to be 0, but then I have 2x1 plus, I'm not sure why that's getting darker, 2x2 minus 2x3 equals 5, and 5x1 plus 5x2 minus x3 equals 5. Okay, so we have this system of equations. Now I can turn that into a augmented matrix: 0, 0, 4, 0, 2, 2, minus 2, 5, and 5, 5, minus 1, 5. So there's my augmented matrix. And what I want to do is get this into reduced row echelon form. So the first problem I see is that this first column, or first row with 2 zeros is not good for reduced row echelon form. I need a 1 you know, up here in this top left if I can get it, and I could do that pretty easily by swapping out a couple of rows. Now, they, in their work, they rewrite this swapping row 1 and row 2. This, they say row 1 and they do a double arrow row 2. Well, I think to be clear, then, you know, you might want to do the same sort of thing up here. Actually, they could be in the same order. I did row 2 double arrow row 1 and then row 1 double arrow row 2, but it really doesn't matter. They could both be the same. But when we do that, we rewrite this and we get 2, 2, negative 2, 5, 0, 0, 4, 0, and 5, 5, negative 1, and 5. Okay, now I'll come over here to the right, and what I want to do is simply multiply row 1 by a half. Okay, so row 1 becomes 1/2 of row 1. And I would actually rather sort of swap those two things, but the book does it this way, so we'll do it that way. 1, 1, -1, and 5/2. And then we didn't do anything to the second or third row, so we leave those alone. 5, 5, -1, and 5. Okay, so here was our, here's our step 0, here's our step 1, here's our step 2. Step 3 then, well, this is good. We want 1 and then a 0, but we need a 0 down here for that 5. And so then what we could do is take -5 times row 1 and add it to row 3, and then put that back into row 3. So we aren't going to do anything with the first two rows. 1, 1, -1, 5/2, 0, 0, 4, and 0. And then here we are taking row 3, instead of row 3, we're going to take row 3 minus 5 row 1. And with that, all right, we get 5 minus 5, which is 0. Another 5 minus 5, which is 0. That's kind of convenient. And then a -1 minus a -5. Okay, so -1 minus a -5, that gives me a +4. And 5 times 5/2 is 25/2. And so I'm taking 10/2 and subtracting 25/2. And so that gives me minus 15/2. And so that's after step 3. Now, at this point, actually, I can see that my system has no solution, okay, because I have that here, this 4x3 equals 0 implies x3 has to be 0, but here 4x3 equals -15/2 implies it's not 0, so that's a problem. However, we can still keep going in our reduced row echelon form. And so now what we need to do is, these first two columns are set. There's nothing I can do. Everything's here is in row echelon form so far, but I need to turn that 4 into a 1. And so I'll simply rewrite the first row. 5/2. But the second row, I want to take row 2 and replace it with 1/4 of row 2, which gives me 0, 0, 1, and 0. And then I have 0, 0, 4, and -15/2. And my fifth step, I need to get rid of that 4 there. I need to make that a 0. And I need to make that -1 a 0. And I'll do it as they did. They actually, when they did it, they did two things at once. So you can do that. I guess actually I'm going to do one thing at a time. So I'm going to get rid of that -1. So I'm simply going to replace row 1 with row 1 plus row 2. And when I do that, I'll get 1, 1, and -1 plus 1 is 0. and 5 halves plus 0 is 5 halves. And then I have 0, 0, 1, 0, and 0, 0, 4, and negative 15 over 2. And then for 6th step, I am going to replace row 3 here. Well, I'll write it this way. Row 3, I'm going to replace that with row 3 minus 4 row 2. And so I have 1, 1, 0, and 5 halves. 0, 0, 1, and 0. And then here, 0, 0. And if you do this right, you never get fill-in of these zeros you already made over here on the left. You should only be messing up stuff or changing stuff. I shouldn't say messing up because it's what you want it to happen. But you should only be changing things to the right of those columns you've already taken care of. So when I do that, R3 minus 4 times this thing, I'll get a 0 here, but since it's a 0 in the last column of the second row, we still just get minus 15 halves here. And now, again, for all practical purposes, we're done, but reduced row echelon form, I should get this last thing to be a 1, and so my last thing I'll do is for row 3, I'm going to replace that with negative 2/15 of row 3. And when I do that, I get 1, 1, 0, 5 halves, and 0, 0, 1, 0, and 0, 0, 0, 1. Okay, so I have that. And again, this thing's inconsistent and so forth, but I can still keep going. And finally, I need to zero out that top thing, and so to do that, I'm going to replace row 1 with what? Row 1 minus 5 halves row 2. And so when I do that, everything's 0 here down in the bottom, so I'm just going to get 1, 1, 0 again, but now I'll get 0 here, and 0, 0, 1, 0, and 0, 0, 0, 1. So there I've done my full reduced row echelon form of that augmented matrix, and what that tells me about my original system back here. So what it tells me about that original system is it's inconsistent because I have this that says 0 is equal to 1. Bad news. Inconsistent. So this implies this is inconsistent. No solution. And again, I didn't have to go this far to see that, but that is the reduced row echelon form of this particular matrix. Okay, so there's an example of using these. Now let's continue. Let's take a look at another example. So this is from 1.4. This is example 1.4.1. And they're saying we have x plus y is equal to 0. X minus y is equal to 1. and 4x plus 2y is equal to 1. Now, when I look at this, what I know is most likely we're going to end up with something inconsistent, but you never know. It could have a solution, but typically if I have more equations than unknowns in a linear system, I will get an inconsistent result again. So we make our matrix. 1, 1, 0, 1, negative 1, 1, and 4, 2, and 1. There's our augmented system. And now I've got a nice 1 right there, so what I want to do is get rid of this 1. Now I could get rid of the 1 and the 4 at the same time with different row operations, but here I'm going to do them separately. And so the first thing I'm going to do is in row 2, replace that with row 2 minus row 1. So row 1 didn't change, so we've got that. Now row 2, and I subtract row 1, so I get 0, minus 2, and 1. And then I didn't do anything with the bottom row, so that stays the same. And I have that new matrix. Now, as I look at that, I'd like to get rid of that 4, so I'm going to take row 3 and take row 3 minus oops. Here we go. Minus 4, row 1. And so again, row 1 stays the same. That's 1, 1, 0. Row 2 stays the same this time. But now I take the 4 minus 4, I get 0. 2 minus 4, I get negative 2. And then 1 minus 0, 4 times 0 is 0, so 1 minus 0, I get 1. Ah, this is nice. Notice these bottom two, they're the same equation, so this will have a solution. All right, so the next thing I want to do is turn that negative 2 there into a 1 to get my reduced row echelon form. And so row 2 becomes negative 1/2 times row 2. And so I have 1, 1, 0, 0, 1, negative 1/2, and 0, negative 2, and 1. Okay, now I want to get rid of the 1 up here. So I'm going to take row 1 and turn that into row 1 minus row 2. And so I have 1, 0, and a positive 1/2. Nothing with these other two, so I keep those. 0, negative 2, and 1. And now I want to get rid of this negative 2 here, so I'm going to take my row 3 and have row 3 plus 2 row 2. So that's 1, 0, 1/2, 0, 1, negative 1/2. And then 0, 0. And now negative 2 times 1/2 is positive 1, and add that to 1, I get 2. Oh, something, I messed up my arithmetic somewhere. Notice, because, right, I can see up here that these are the same equations. So I should have 0 and 0. So what did I just do? I'm pretty sure I'm okay here. What kind of voodoo math did I just do here? I did, 2 times, I think I said negative 2 times negative 1/2. But it's 2 times negative 1/2, which is, this won't be the last time I screw something up. Okay, so that's 2 times negative 1/2 is negative 1, plus 1 is 0. And there we go. and that is in reduced row echelon form at this point. Okay, and so what does that mean? Well, I can read that off that says x is equal to 1/2, and then y is equal to -1/2, and there's my solution. So there we go. We had an extra equation, but it turned out it didn't change the solution. That equation, that original equation, let's see, can we see that? No, it wasn't either one of these two equations multiplied by something, but it was a combination somehow of those two equations. And at any rate, we do have a solution. So that was another example of using our reduced row echelon form. Let's see, 20 minutes, that's plenty for this. We'll do another video.